Hello, nice to see you again. I'm Chris. In this video, I'll use the OMRON CPU with an X1021220. It's a very powerful CPU. Then I'll install a safety module called SL5700 to the right hand side of my CPU. By using this module, then you can build a FSOE connections or chip safety connections. And for the adapter side, in this tutorial, I'll use a CIP Safety IO block module from Turck. The model number is TPIP054FDI4FDX. This is a chip safety IO modules. Then I'll use these configurations to build a chip safety connections and normal Ethernet IP connections. And in this video, I will show you a complete project. Then I will mention you there's so many points you need to take care when you create a project with OMRON and Turck modules. And here is a screenshot from the menu from the Turck module. It's a page 70. So in this page, it shows the safety connections. If you use a chip safety connections, what is the input assembly instance numbers, how many data pipes, and the safety output, and also the safety conversion assembly instance also. Why I show in here? Because if I think in this moment Semantic Studio cannot import the EDS file that you download from the Turck homepage, so you need to create yourself. But if you need to create the EDS file by yourself, then you need to input all the parameters. For example, here you need to enter the vendor, the product type, the product code, and the region, and you also need to input the safety input and output and the conversions assembly instance. Even it just have some small mistake, then chip safety by the Turck module will reject your connections. So, but don't worry, in this tutorial, I will go through these items one by one and to create a EDS file together. Okay, so before we go through the project, I would like to turn on my camera and then to show you a configuration that actually I'm using in this tutorial. Let's go. Okay, here is the main configurations that I use in this tutorial, and here you see I'm using an OMRON CPU and it is an NX1. I forgot the real model numbers, and here you see there's a SL5700. It is a safety module to let you to handle the chip safety connections and all the safety stuff. And for here is we're using a Turck chip safety IO block. So now it's in a low mode connections. We are connecting to eStop. The eStop is the eStop from Pilizi. And here is the input and this is the output. So if you use the Ethernet IP before that, you know all the LED have the meaning in the chips. In the chip standards, they will standardize which LED the meaning of each LED. In here, you see MS and NS is in turning on, not flashing, not have red, so it means the safety connection is okay. And also in the OMRON side, you see in here for the SL5700 that is showing 8 line something. Actually, no need to care about this number if this normal. If there's any Ethernet, any safety connections error in here, then you show this IP address that with error by two numbers. For example, he'll show you 192.168.1.10 in hex format for each numbers. And now you see it's not flashing, so it means the connection is okay. Now we can start to go through the project to show how I configure the chip safety connections. Let's start. Okay, now we will start to make our project, but before first I would like to show you so many hints to how to configure the Turck chip safety modules and how to match it with the OMRON schematic studio. Let's start. The first thing, I would like to access the web server of the chip safety module in Turck. So go to your browser and you like, and then search OMRON.Let or enter the IP of your Turck module. And here, okay, I log you again. And here is the web server of your chip safety IO block module. The first thing I would like to log in, go to here to enter your password. Default password is password. And then he'll show now I'm logging as an admin, then with my IP address. And default to show this station information. Then in here you can check the firmware version and the Ethernet IP version, and how are you configuring the IP address in here. And actually here I'm using the rotate switch. By the way, you can use the CIP server and any type of addressing, but you need to reference the menu to adjust the rotate switch. Okay. Then I'll just show you some useful features I use in this web server when I trying to configure this Turck chip safety module. The first thing I've used it is a Ethernet IP memory map. This is a very useful function that I also will show you a little bit later when I trying to configure the OMRON project in the schematic studio. In here, it's a very clear mapping, clear table to show you what's the input instance, the output instance, and how many works is using. So in here, for this Turck module, then you're using 103 for the input assembly instance. It's using 10 works, and for the output, you use 104 assembly instance with 3 works. Then here is show you which date or which work and for which bit is for what kind of meaning. Then here is also have output, not just input. In here I use this mapping to create my data type and also to encode the data that I receive from Turck modules. Okay, and then the other things you use is the system. It is station configurations. Here you can reset your module to factory with the factory default. I think it's better to use this way because, for example, when you buy a new module and get a new module from somewhere, or you run a module from Turck, it's better to maybe you don't know what kind of settings inside. I think it's better to reset to the factory default than to a clear conditions. Then you can create your project again. And the other things I use is the network configurations. So network configurations, here is the SNN numbers. It's very useful. You need to use it to match what the SS number that then you configure in OMRON side. You can just imagine this SS number is a magic number that depends on your time step, and to generate a hex number, then the adapter need to exactly to connect to the scanner that you want to connect, and then just enter it and then submit. It's finished. And here is the safety status. Then I didn't use it here. The fiber speed, it is a bit just showing the input work 0 with the actual value something. So repeat again, you will use the Ethernet IP memory map, you use the station configurations, you use the network configurations, then you may also use the fiber speed. Okay, then now we can open the Smart Studio. So I'll show you step by step. For example, you need to configure the IP address. How to configure it? Go to controller setup, built-in Ethernet IP port settings, and then go to here, here is you need to configure the IP address to match your network. That's all. And then you need to configure the SL 5700. As I mentioned you before, that in this tutorial I'm using this safety module, right? So you need to go to go to CPU extension rex, and then click here, click somewhere. I think click here is okay. Click CPU rex, and then you need to insert the SL 5700 into your hardware configurations. And I need to also mention you that when you drop the, for example, I just show you here, safety CPU. And here is SL 5700. It only show version 1.4, but for example, you get same theory. If you run the device from OMRON, maybe they cannot provide the latest versions of the safety CPU device for you. Then if you configure the module as V1.4, but your hardware is 1.3, you cannot use it. So you need to click the show all version and to configure exactly the same version to your configurations. It's very important. Okay. So I hope you configure the hardware configurations correct, and then we can configure the safety network first. One time, then you configure ASL 5700 into your hardware configurations. Then you go to drop down list, then just select the safety PLC, and then okay, let me just close all this one. I think save it and go to here. And first thing, you need to configure the CIP safety connections. Then go to safety communication, safety, and Ethernet IP safety connection settings, and go connection settings. This is two settings in here. The connection setting is when you configure your CPSA scanner. When you configure your CPSA scanner, and for the IO assembly setting, then you configure your CPU as a adapter, safety adapter. So you can configure both same, but in this tutorial, I just configure my OMRON controller as a chip safety scanner. So click the connection settings. Then how I create a device in here, but I'll show you how to create the Turck safety device by reference on the screenshot I showed you before. So you need to go to EDS library for chip safety. Here's the bottom here. Then you need to press the new EDS file. Then here is a Windows here for you to input all the informations. I'll drop it to be big here, and I'll go to slide here. So, and first of all, vendor ID. Vendor ID that is 48 in here. Just enter 48 in here. And the vendor name is doesn't show in here. You can just input Turck or anything, but depends on your vendor name and product type range. The Smart Studio will actually depends on all your stuff import in here to manage their EDS library. So just input something is very similar or very same what the module that you're configuring. And if you want to configure exactly, you can go to you can use EDS tubes, then to open the EDS file that you download from Turck website, and then to set exactly. So, and here I will just put Turck. Then for product type is 100. Okay. And then product type strength, it doesn't show in here. You can just put, for example, safety IO, safety IO. And then for the product code, what is the product code? Product code is here, 20014. And then product name, you can just put here this one. I just put this one. For example, why? Here, copy and paste it, and okay. And then the B region here, as you can see here, B region is 3.001, so in here 3.1, finish. And then you need to configure the safety input. For the safety input, you can see here there's a connection parameters. The safety input assembly instance is 1024, output is 1279, and using 8 bytes. So the same here, 1024, 1297, and then 8 bytes. Great. Okay, for the output, using 1279 for input assembly instance, and output assembly instance 1056, and using 8 bytes. So same. Forgot it. 1279. Okay. 1279, and output is 1056, and then 8 bytes. Great. And then finally, you need to configure the conversion assembly. It's here 1088. Great. And then for the safety format, you can choose external only, and then press OK. And then the Mark Studio, we automatically create EDS file for it, and then press OK. Then the new EDS file will generate and import in the EDS library in your engineering tools. Okay, and then after that, you can just choose here and just drop into the network. Okay, then after you drop your network, the first thing you do, double click it. You need to set your IP address to make sure to match that what you are configuring now. And then you need to go to set the safety network numbers. So here's the safety network numbers. So you just copy it and then go to the network configurations in the web server and then paste it. That's all. Okay, and after that, you need to configure the EPI time for input and output to match your applications. And after that, I think for safety is done. Then you can create a program, but for the program, you need to mapping. Go to the IO map here. Sorry, IO map. Let's close this one. And then here you see safety input and safety output. You can just click here, right click, and generate, create device variables. After that, in the data global variables tabs, that all the variables you automatically define in here. You no need to create it one by one by hand. Then after that, you just need to create your own safety program. In my case, I'm using the program 0 here. It's a very simple safety program. When I receive a safety bit, I just return it back. Very easy. Okay, for these safety connections, okay, then now we can configure the normal Ethernet IP connections. Actually, I told you before that the Turck IO module, they provide two types of connections for the user. The first one is Ethernet IP normal connections, and other one is chip safety connections. And in this tutorial, I will use the OMRON CPU to connect both this the normal one and chip safety one to my OMRON PLC. So open the drop-down list, go back to the new controller. And the first thing, you need to configure these chips Ethernet IP connections. But before that, you need to define the global variables. So here, go data, go variables, and this is in normal, not the safety variables. Okay, it's a normal program variables. I define two data from Turck and data to Turck using 20 bytes of input. Don't forget to select input here, and for the output register, and select output there. Why I use 20 bytes of input and 6 bytes of output? Because when I go to the mapping. Then I'm using input is 10 works and output is 3 works. So multi-dimensional you can directly define works, but I like to use bytes. Okay, and after that you can start to configure your Ethernet IP configurations. So how to do this? Go to tubes and go to what? Tubes and Ethernet IP connections. And because my CPU has 2 ports, right? So I'm using this port. Right click, edit, and go to register all the data that you need to using as a Ethernet IP variables. Okay, then you can go to the connection tab, and here maybe you think it is a little bit strange, but for the Smart Studio that you can import the EDS file that download from Turck homepage, then you can configure the low mode Ethernet IP connections. Okay, so how to do this? That's very easy. Go to display EDS file library, EDS library, and then press install to choose the file that you download from Turck homepage. Then install in here, then finish. Okay. And after that, you can just press plus button in here, and then enter the IP address of your Turck modules. For example, here I maybe 192.168.1.112, and for the model name, just choose Turck device. I think it is start from T, right? T this one, and then choose the version. Why? A second, choose the version, and then press add. It's okay. And then you create a target device like here, then just drop to here, just finish. And for here, the input, the target variables in here is a instance. So the input instance 103, the output instance 104. Because of here, right? Input is 103, output is 104. Because input 103, 104 in here. Then for the size, 20 bytes makes sense. So 6 bytes makes sense. That's why the reason that I use bytes, don't use work, because in OMRON also they count all the data in bytes. And choose the metadata, what the variables you want the mapping, and then finally the connection type. You can choose point-to-point or multicast. And then you need to enter your RPI. In my case, it's a 10 millisecond. Done. Then you finish the Ethernet IP connections. Okay. And then after that, you need to create some program. I will not explain too much in here because I released a text version of this tutorial maybe on next week. Then you get more information about how the data types. I'll just show in here. I make a data type called Turck chip, and inside I will have this Turck chip safety, chip safety status, status work, or chip safety status for each port information for the few bus bits or something. And I have a function box to get. I also have a function block in here to encode all the data that I receive from Turck IO modules. Then, for example, in here I move the first byte into some buffer, and then for the first bit it is module dynamics variables. First bit, right? Work offset 0, bit offset 0, and then 1 bit link. So here, and then for the third one, it will be station configured change. So here, work 0, work offset 0, bit offset 3, and with 1 bit data. I have not explained too much in here. And here I was using functions in here also, because when you check the mapping, you see from C0, from the port 0 to port 7, they also the same mapping with same meaning, just a different web offset. So I create a functions to do this one, because maybe I don't think it will not happen, but if the Turck one day they show you I change the version, the firmware, I add some state a bit for my port. So because now they still have 0, 1, 2, 3, 4, 5, they don't have bit 6. I think now bit 6 is spare a bit. Maybe in the future they will use spare bit 6 for some special dynamics. You don't know, and even I also don't know. So if you use functions, then you can only just reprogram one time, then you can reuse it. You no need to program it 7 times. But this just depends on you. Okay, so and finally, I will open the. I will make the main program here. I use a ladder here because in default they create a ladder. The first time I call the function block I created before, and then I will turn on the bit. If I turn on this device, I will turn on the first bit of the data sent to Turck, and if they off, I turn it off, and I also check the e-stop. That's all. And then finally, if you create all the program, don't forget to download the safety program, down the normal program, and down the Ethernet IP setting. So how to go? I show how to go down the Ethernet IP setting. Go to online. Yes. Okay, because now I'm trying to monitor the safety application. It show me the software will be a bit small, a bit slow, but that's okay. And then go to tubes, Ethernet IP connection setting, and edit. Here you translate to controller. Just press this button to translate your Ethernet IP setting to the controller also. Finish. Okay, now we can do the Turck side. Okay, here is the Turck project I create in here. Before that, I show you before we set your Turck module to factory setting, right? So you need to configure all the things again by yourself. It's a very good practice that you do all your things from zero by your hand. Then you know what you know and you know what you don't know. The first thing you hear, and don't worry, I think next week I also release a text version of tutorial, and that time I will show you a little bit more about how to use this software. The first thing you need to download the software, right? But this software needs some. Okay, so to search it, okay, Turck Safety Configurators. Just go to my browser and search Turck Safety Configurators, and here, when you try to download it, you need to get a coupon code, right? This coupon code is you need maybe contact your local office of local Turck office for the sales, then for the sales or some stuff, and they will give you a coupon code. Then you can enter the code in here, then put the next button, then you can download the software. And when you install the software and found the software also request you to enter this code again. So you need this coupon code to download software. And one time you download and install in here, so here is your coupon. Here is your Turck Safety Configurators, and so the Turck Safety module. This module is not just a I/O module. It can also allow you to build some simple logic inside the I/O module, that it can be a local controller. So for example, in this case, I will monitor my e-stop, and then I'll have a delay, and then I could try to turn on my output, but I need to monitor a device. So which device I need to monitor? This device comes from build bus. So you can create all your program like here. You can create the program here to decrease the workload of your safety controller. Or even you no need a safety controller. You can just use the field bus, normal Ethernet IP connection to return the safety status inside your controller. Then all the safety logic is run inside your Turck I/O module. It's also possible. It depends on your applications. Okay, so the first thing I will show you is you need to assign all the data. How to assign? Go to here is the output assignments. Is a mapping here. You need to map manually what kind of data that you need to feedback to your device, or you need to receive from the device. Okay, in this case, I will send the for example chip safety output status. So here you have a column. It's called chip safety. Other one is called field bus speeds. You can choose in here and here. Then you know how many bits you still can use in here. In my case, each one I still have 8 bits empty for me to use. Okay, so for here, for example, this is the e-stop signal. I map it to the chip safety and also the field bus speed. What is the field bus speed? Right. I close this one. No need. And here's the web server or the Turck chip safety module. And when I slow down, here is the field bus output mapping, data mapping. It is meaning this speed. And then so I just you can do easy select here and select what kind of the directions, the how to say the which bit do you need to assign. So here's by 0 by 1. Yes, also by 0 by 1. And just that's all. Then you can go to and then compile your project by using the check the project, and then press here PC monitor. PC to monitor mean download your project from your local PC to the I/O module, and you can also upload the project by using monitor to PC. It depends on you. Okay. So finally, I show here the field bus. I show a little bit more in here, and then I will try to show you the result. And double here, you see FP00. It means the by 0 bit 0 of the Ethernet IP connections. Okay, it's output. And here is the input address of 01. This is the first. Okay, so here I show the camera again here. It means I'm monitoring this e-stop, and here's the input and here's the output. Okay. So finally, you can press this glasses icon to online. Now you see there's a red line here. So red line is mean the connection is true, and red line is mean false. It also is line called yellow. Yellow is mean waiting some conditions. It may be time delay. It may be waiting. It depends on up and down. Okay, so when I try to here, okay, when I try to turn plus the event stop, you see what happened in here. Okay, you see here it's being red because no condition is be true anymore in this case. Okay, so and then I will release my button. Please pay attention to this line and this line. You see now this line changed to yellow because I'm rating it now. It will be true, and now it's waiting for this condition. Now after 2 seconds, the delay turn on and true. Now it's waiting for this line. So where is this line? We go back to our OMRON software and then go to the program. Oops, over the program. Here, actually, it's waiting this bit data to Turck bit 0. And I mentioned that before that FP00 is mean by 0 bit 0, right? So it's meaning this one. Why 4? It means now here is the where offset 2, right? Offset 0, 1 is 0, 1, 2, 3. 0, 1 is work 0. 1, 0, 1, 2, 3 is work 1. And 4, 5 is work 2. So it's y by 4. And then because it's waiting a defense up down. So how can I do this one? I think I can show here. Okay, I'll show you. Try to show you this bit more easy here. Great. Let's go. I can slow the bit down here. And here, okay. In OMRON, you can use Ctrl+Shift+J to turn on something and Ctrl+Shift+K to turn off it. Okay, let's see. Done. Using a green. It means that great, the alarm is turned on. Okay. And when I try to press the E-stop, you see that in the field bus line here, it will also be turned off. Let's see. You see this bit is turned off because we map it, right? In the output assignment, we map this port signal to the field bus bit signal 0. That's why you turn on. Then you turn on or turn off, depends on the conditions. And then when we release it, then E-stop signal is okay, and then we can reset it by using some hotkey. Great, turn on. And then finally, we can go through to the safety CPU for the safety program in here. And that I hope yes, here. Okay, I will proceed again. Okay, you see it become the true and false. I think it's done. And finally, I'll show you some troubleshooting tools that easy for you to check the chip safety connections and the Ethernet IP connections. Okay, go to here. I think it's this bottom. Yes, it's a bottom called chip safety monitor. Then you click here. Then everything still normal and success. If you have any error, then we show error in here. Then you can see the external error going in here, and some reason and description text. And also for the normal connections, you can go to tubes, Ethernet IP connections, and right click monitor, and go to status. And you know the status is 00. It means now it's no error. Then you can, when you go to Ethernet informations, you see the last package when you receive it or something. Okay, I think in here my video is enough. And if you have any questions, please feel free to comment or to write down the comment. I'll try my best to answer you. And don't worry, I will release the text versions of this tutorial very soon, and I'll also leave the link to let you to download the EDS file for this of the Turck module in Smartick Studio. Okay, I think my video is too long in here. I hope you like this, and see you again. Bye bye.